The scene of a major disaster, such as the aftermath of an earthquake or a hurricane, is frequently one of damaged buildings, dangerous hazards, and emergency responders desperately trying to help as many people as possible. Using aircraft in these situations is nothing new, but increasingly people are using unmanned aerial vehicles, or UAVs, to help in this space, exploiting their versatility and cheap running costs. Now, UAVs have a host of bad media coverage stemming from the reports of their use in warfare. But since they're easier to deploy than, say, a helicopter and require less specialist training and equipment, it's my hope that within a few years, people will come to see them as a useful tool for saving lives rather than taking them away. Flying a UAV using a remote control is all very well, but it often requires at least 2 people, one to fly the vehicle and one to look at the feed from the camera. Now, people in a disaster are a very, very scarce resource, and we need to reduce this ratio. The way we can do that is by allowing the UAVs to be more intelligent and autonomous. This is why computer scientists like myself are trying to develop algorithms that allow UAVs to communicate with each other in a simple way while making complex decisions as a group by deciding what actions they can use to meet some kind of mathematical goal, like performing tasks in the shortest amount of time or finding the maximum number of people. For example, think of a fleet of high-up glider UAVs searching a space and identifying areas on the ground as imaging tasks for lower helicopter UAVs to look at. When I tackled this, I took existing research as a jumping off point and combined explorative algorithms with this task allocation problem. In the solution, not only do the UAVs not have to be in full communication with each other, they don't actually have to know themselves about all the tasks being discovered, and they can reach a group consensus just by passing a few numbers backwards and forwards as messages. What I'm now hoping to do is apply this same rigorous, intelligent design to groups of UAVs exploring an area with an emphasis on finding people in the areas of highest risk. For example, there might be available data on houses and where people are living, and also which of those are at most risk of, say, flooding. I want that combination of data to drive the search patterns of these UAVs to find the people in most risk, while sticking to the principle that they do this as a team with no one central point of failure, and find as many people as quickly as possible. There's still an awful lot of work to be done in this field, but it is my sincere belief that in the future we will see situations where, in the event of some disaster, man-made or natural, a fleet of UAVs could be quickly deployed to search the space for victims, coordinate with each other and emergency responders, and ultimately save lives. Thank you very much.